Our next event is our first keynote speaker, Sebastian. And I'm actually really excited to introduce Sebastian, and really he needs no introduction. Hopefully this doesn't make him feel old, but I actually first read about Sebastian in a magazine when I was in high school. So it's pretty cool that I get to introduce him today, and maybe that I get to potentially call him a colleague at Stanford. Sebastian is a fellow in the National Academy of Engineering. He's done really, truly seminal work in a pretty wide range of fields, which I think is really impressive. This includes his work on robot mapping and localization. He also led the team that won the DARPA Robotics Challenge in 2005 on autonomous driving, and I read that the Stanley robot is actually now in the Smithsonian. He also pioneered work in massive open online courses as a co-founder of Udacity, and most recently he's been working on automated homes and AI for healthcare. I'm really looking forward to hearing his talk, and please welcome him.
All right. It's great seeing everybody. Raise your hand if you're from Stanford. Okay, Berkeley, overseas. More Berkeley people than Stanford. That's impressive. Wow. Oh my God. Anywhere else? Yes? NVIDIA. That's like Stanford. Okay, let me, when I got invited, I thought it was like one of these spam messages. Who would ever invite me these days to give a talk? And then I was thinking, what should I talk about? Like, I haven't done anything in AI and robotics in a while. And I'm really old, okay, like twice your age. And then I decided, you know what, I might as well just kind of tell you the story of my life a little bit and what I've learned, and what advice I would give to my younger self, like this guy. I was young at some point, and I found this photo. So let me indulge you a bit on the type of things I experienced and what led to what, and hopefully there'll be something in there for you that you might take along on your journey as you're engaged in something similar that I've done. My academic life started in the 90s, when most of you weren't born. This is an old photo I've dug out from Carnegie Mellon University. This is Tom Mitchell's snap, and I challenge you, Tom Mitchell is actually in the photo. Challenge you to find him. I'm the guy with the red shirt on the left side. I used to have hair. And in the early days, I was hardcore academic. I went to this thing called robot competitions. AAAI in '94 ran these things back in the day. They were centered around domestic tasks. Like this one was called Clean Up the Kitchen, except there was no kitchen. And it was believed that these big boxes that the robot would lift would be representative of kitchen trash. But all the academics at the time would meet there and just get together and fight. And I still remember, like, we wouldn't sleep. I was so tired. I was in charge of the robot software that I would hit the start button, look up, and all the robots were gone. And my team told me, Sebastian, you just took a 20-minute nap on the keyboard. It was intense. But I wasn't satisfied because I always felt like I want to do something for the real world that helps people beyond just being in a competition and showing how smart I am, which to me, most of academia was actually that. So I went into, try to find an application where can I take my kitchen cleaning robot and do something useful. And what came to mind was a museum. So in '97-ish, with Wolfram Burgert and others, I first went to a museum in Germany, Deutsches Museum Bonn, and then a Smithsonian Museum, where we built these robots that would give tours to people. Like, you would come in, and a robot would greet you. It's like what, 25 years ago. And you'd say, push a button and say, I want a tour of this part of the museum, and drive you there and give you a tour. And that's the first time I really encountered something of academic value, because these things just didn't work. They would get lost. They would fall down staircases. They had a really hard time surrounded by hundreds of kids, being able to kind of keep track of where they are and how they're navigating. So out of this came, this is Frank Diller's work at Georgia Tech now, was my grad student, the idea of really thinking about perception problems and problems of localization and state estimation and so on, and eventually led to this kind of inclusion of robotics and probabilistics and statistics that I'm somewhat known for these days. This is a very first seeding map of the Smithsonian National Museum of American History, a sonar map. We didn't quite have lasers at the time, they were too expensive. And then this led to, over the years, to an entire body of work between me and my collaborators, Dieter Fox, Wolfram Borgert, on something called probabilistic robotics, which I assume some of you have heard about. Yes, no? Okay, everyone's quiet. One person says yes, thank you. 2, 3, wow, woo! Famous. Translated into, I think, Japanese, Chinese, Korean. Strangely to me, I mean, this was driven not by my attempt to build theory. It was just, we couldn't make these robots work, and they would get lost and didn't know where they are, and they couldn't quite. And after the time, the paradigm robotics was, state was trivial, like planning was hard. All the smart people worked in motion planning and combinatorics and so on. It turns out it's really hard to make a robot arm, even if you know everything, to make it plan. It's like W or singly exponential in the number of degrees of freedom, depending on what you believe. We couldn't get the basics to work. We just couldn't make the robot even navigate from A to B. And that was hard for us. It wasn't a computational problem, it was a perception problem. And I would say the entire body of work that's filled massive number of proceedings on statistics, robotics, and Monte Carlo, and whatever, and SLAM, really arose out of this kind of basic necessity to build something in the real world. Then I, done with that, figured, what else can I do? How can it be useful? And I fell for this kind of somewhat stupid Japanese kind of idea that robots should go into healthcare and elderly care. And they have a place there. I mean, intuitive surgical, we talked about, is amazing. I ended up building a project called Nurseb Project with Joël Pinot and Nick Roy and others. They will go into nursing homes and try to see if they can make a robot do something for the elderly. And the elderly were very excited. Mostly men turned out. And I didn't quite know why. Mostly because we had on our team a very attractive female grad student called Joël Pinot, who's now professor at McGill. And they loved talking to her. They didn't care about the robots, but they really wanted to get engaged with us as young people in a nursing home. But we kind of got our first feel for, like, what does it take to do something for elderly people? And it turns out to be complex. It turns out there's no single thing to do. It's actually a really deep task. How can you build robotics that really makes people's lives better? And while we published a few papers, we kind of gave up. Next phase in life moved into something more mundane. Carnegie Mellon. Pittsburgh has like tons of abandoned mines. For whatever reason, I got into that to kind of think about how can you use robots to explore these mines. They cause problems like subsidence, and 11 of them have a fire inside that's been burning for decades. One is under Pittsburgh International Airport. So I spent a good amount of time with my colleague, Brad Wilker. Here's some random photos I just dug out in Pittsburgh. So if you ever think about going to Carnegie Mellon, keep these pictures in mind. Just kidding. That's right south of Carnegie Mellon. This sludge, this orange stuff is extremely poisonous. These mines are full of, have no oxygen left, so if you go inside, you're not going to come out. So sending robots in. And out of this came this kind of body of like thinking about mapping, SLAM and mapping and GPS-denied mapping, kind of that led to, I think, a lot of papers kind of understand how to build maps, navigate maps autonomously with robots, and became a very vibrant field. Around that time, I decided to move from Carnegie Mellon to Stanford, which I really loved. I talked to my Stanford colleagues and given me tenure, which is actually, if you ever need this skill, call me up, I'll tell you how to do it. So they hired me with tenure, and they gave me the freedom to do something crazy. And the crazy thing coming along at the time, very optimistic, was called Darpa Grand Challenge. It was a robot competition by the US government. It just took place the first time, and this picture kind of summarizes the very first iteration of building the very first self-driving car, okay? I can show you videos of videos, but that picture summarizes it really well. This is one defense contractor called ENSCO that flipped over, I'd say maybe 30 yards out of the gate. The best team at the time did about 7 miles, went on fire, Carnegie Mellon. So we built at Stanford this thing called Stanley, a early robotic car. This is now 2005. Most of you are born at the time, okay? And it was hard, like really kind of get this thing to work. This is the day the New York Times visited us and wrote about us, okay? What they wrote was not very kind to me. This is Carnegie Mellon a few days later. Our enemy, in some sense, our rival. We love those guys, but I'd obviously moved from Carnegie Mellon to Stanford. And these were the declared winners. They were certainly, in many ways, the stronger team. And then come the race along, these kind of bizarre things show up. Out of 196 teams, 23 go to the race. And our robot now is the very first time does something actually useful and goes to this race, drives alone, no person inside. Behind it, a government chase vehicle with an emergency stop, but otherwise on its own, driving 131 miles in just over 7 hours through the Mojave Desert. This is the moment where we passed the top-seeded Carnegie Mellon team. We liked it. My friends at Carnegie Mellon didn't like it as much. This is a treacherous mountain pass called Beer Bottle Pass. Nothing to do with my German heritage. And here you see the robot covered in dust and have to be able to basically make life and death decisions. This video, by the way, is taken from an hour-long PBS special, Nova special, that I encourage everybody to watch. You can see my younger self saying stupid things. But after almost 7 hours, this robot made it. And Larry Page was there, many other people were there. This was kind of the moment where I think people started realizing there's something there that you can build and something useful, self-driving cars. As mentioned, this one is now stuck in the Air and Space Museum. Why a robot, a car would make it to an Air and Space Museum behooves me, but it's there. And that museum is being renovated right now, but it's been an exhibit since 2007-ish. As a little side project, we took that technology and brought it to Google and built up this thing called Street View. We built the biggest image database around the world. These are not robots, they're driven by people, but the technology for getting the data and integrating it into a system came out of robotics. So we built the world's largest image database, and on the side also built the world's largest map ever built, which is the map inside Google Maps. That was built by us, my students and me. It was an interesting story to just scale up and understand how you build something that everybody uses every day. So all of you use that work every day. And then we went to Stanford and started Waymo. And this is an interesting photo because this is a younger self, and Chris Urmson on the right side, and Anthony Lewandowski. And we decided to just give it the impossible a try and build a self-driving car that could drive on public streets safely. And to you, it looks like completely trivial. Why is this old guy talking about it? But to me at the time, in 2009, it looked like, oh my God, this is really difficult, really hard, really challenging. And one thing we did really, really well, which is kudos to Larry Page, is we kind of set ourselves a challenge. We said, okay, here's the thing we have to do to succeed. And when we do it, we're very proud. And that challenge was to drive 1,000 reference miles across California, through San Francisco, Lombard Street, Market Street, around Lake Tahoe, Highway 1 to Los Angeles. Stuff that looked really, really, really hard. And we knew we had to do this reliably to build a self-driving car that could one day drive without a driver inside. But it was also unthinkably hard at the time. It took us about a year and a half. We built these 8 Priuses that drove around in public. They looked like this. Most of the time, people didn't even know what we were doing. Very secretive until the New York Times found out. And then eventually, we were able to drive these 1,000 miles, about a year and a half in, 10 engineers. And then moved on from there. Built bigger cars, tiny cars. We actually invented what I think today is still the dominant architecture in this desk. It's kind of a microservice architecture, kind of like ROS, but not quite ROS, which processes data into a 3-dimensional worldview and uses that worldview to make decisions. Every company in this space, and there's like dozens, uses it except for Tesla. Tesla has a different philosophy. And even in 2011, we were able to kind of come up with a very first full end-to-end taxi service on Google's campus, Robotaxi service, 10 years or 12 years ago, where these golf carts would come out, self-driven, pick you up somewhere on Google's campus. You could get your Android phone, didn't work with iPhone, but it worked with Android, to get them to summon you and carry you from A to B. And in that process of driving around, you could either drive it yourself or you could be driven. It was your choice. So it's kind of a very early version of Waymo today and Cruise today. I guess Cruise stopped driving, but Waymo is still driving in San Francisco. Hey. All right. That's the typical Googler. Free food at Google, you can tell. And he is entering his ride and badging in with his badge, Google badge, and then this thing just drives him around. At the time, I mean, there's stuff we don't talk about that much publicly, although I can do now because my NDA expired. But we did all kinds of stuff, like stuff you wouldn't believe. Like if you drive millions of miles, you see everything. Like this was a case where our self-driving car was driving and didn't quite know what to do. And I play this because when you go into the real world and build something real, the type of stuff you experience is so different from what you expect. One day we had a blowing trash bag, like a shopping bag, blowing across the highway, and our robot thought it was a rock that was flying across the highway, and I got scared and broke and begged, and we realized, oh my God, we have to build a plastic bag detector type thing. When you look at today's accident rates, specifically kind of some of the Tesla accidents where people don't pay attention, they're all related to something that's incredibly unlikely, it's something you don't expect, but it's important to in the real to understand how important that is. So we spent endless time testing. We bought like 500 cars and ran like crazy. And obviously today, the car was launched commercially in various places. Today, in front of my house in San Francisco, these guys are driving around. I have an app. I can summon them. They're really fun. So you can try it out. They're not a viable business yet, but I'm extremely excited. I believe this technology will transform the world in a way we've never seen before. It's going to make driving safer. We still lose about 1 million people worldwide every year on traffic accidents. It's going to be driving more economical. Eventually, it's going to be a fraction of the price of car ownership. It's going to make the cities greener. If you care about anything but global warming, you want fewer cars. The fact that this campus is full of parked cars is a travesty. Eventually, they're going to go away, and we can share those resources and be a better world. And I'm really excited about this. There's a whole bunch of spin-outs from my grad students. The joke is that pretty much every self-driving car company here, the CEO is my former student, like Neuro, Zoox, Aurora, came out of Stanford. Zoox is Jesse Levinson, incredibly smart person, built this company. And just to give you some other projects at Google that I was involved in, I really got obsessed about transportation and asking, like, what's the future of transportation? And my good friend Larry Page kind of kept telling me, look, Sebastian, you're so ground-based, you should be more air-based. And think about the airspace as a great way for transportation because it's unobstructed, you can go straight line, and all you have to add is a little bit of lift, and then you can be away from all the obstacles on the ground and traffic lights and so on. Out of that came Google Wing. It was done with Nick Roy, professor at MIT, former student of mine, that in early days started wheeling packages to people in Australia, and now it's become one of the dominant companies next to Metronet and Zipline in this space here in the US. I think it's still in infancy. I think there's a lot to be done on transportation airborne. That's going to be a game changer as big as the car was in the 20th century. So I highly encourage you to get into that field because it's very, very useful. We went to the border of space. We built these kind of balloons that would drift up, lighter than air, so they just fly up. And we showed to the world that a network of balloons can provide communication to rural Africa, for example, where all of a sudden the cell phones would connect directly to these balloons, and all of a sudden you had coverage at places where coverage couldn't be afforded. And I spent a lot of time with Larry and others to think about human transportation in the air. In a company called Kitty Hawk, we built these vehicles that I see as the future of cars. They can take off vertically like a helicopter and then fly like a plane, a bit like a human drone with like slight modifications of having a wing. We can talk about why a wing is useful. But those guys, we built over 100 of those and similar systems. They could fly roughly at a third of the energy of a Tesla, at twice the speed. They're highly redundant. They have 8 motors, so you can lose one, not a big deal. Most aviation people tell you that's not the way people normally think. And I think they can be built eventually at the price of a jet ski and really democratize transportation even more so over what is the case today. So that vision still stands. It's an incomplete vision. There's a whole bunch of companies now, some of them SPAC'd, went public, like Lilium or Joby Aviation, pursuing this on a commercial scale. There's a lot of unknowns about regulations, requirements. But I derive my optimism from the fact that the sky is basically empty and that the technical capabilities are all there. So you can actually build an amazing new transportation system up for anybody up here to grab and do it. It's not done so far. And then as a last side note, a little bit on other robotics projects. I'm involved in a whole bunch of stuff, including at Google. This is one I just spent a week with, Nimble, which is a Stanford spin-out by Simon Kalucha. This is one of the few public images you can find. but robotics in warehouses, trying to change fulfillment centers, packaging of packages and so on. It's a massive industry that is being too disrupted. So, look, I guess you guys are amazing scientists. I'm not. I don't know why I was invited, but I want to kind of share a few thoughts and perspectives, and that's really the last, whatever, 5 minutes of this presentation before Q&A. What did I learn? Like, what advice would I give to my younger self as a roboticist? And it's eye-opening to look from the other side and kind of think about, like, what is the type of stuff you would do differently and would be guiding me differently. And I think there's only 2 lessons for me. There's simplified speaking, add value and capture value. But let me dive in. The very first thing is, I think robotics is not a purpose in itself, and we all get carried away with like building a gadget and doing some math or what have you, writing an algorithm, improving its correctness, and so on and so on. But let's not forget, as scientists, I mean, as an educator, it's perfectly fine. I'll let you do any kind of stupid project and get smart and so on and grow up. But as a scientist, my ultimate aspiration has to be for somebody, right? And it can't be for my peers or my colleagues or my students. It can only be for the world. So how do I influence the world with the technology I built? How can I build like Google Maps or something like that? This is possibly the best image I can show, and this is always on my mind. So every time someone pitches me a robotics company, that's kind of what I come back to, which is my fictitious grandmother. It's actually not my grandmother. Mine died in 1994 or so. But it's my fictitious grandmother, which serves as the person to understand what you do in robotics. So this is the person I run my robotics project by. Like I say, look, if I could build you an NP-complete or NP-faster planning algorithm for ergodic manipulators in KD space, is that useful? And she'll probably say, huh? Okay. But if I go to her and say, hey, you know what, lady, I'm going to build a car that picks you up and drives you, is that useful? She's going to say yes. So the very first check that I think I give myself a B, not an A, maybe a B plus even, of like, what can I do in the world? The very first check is it actually useful? And not is it useful to us roboticists. For us, we know what's useful. Everything we do is useful. The type of paper we publish are useful because we love them, right? And our colleagues love them. We drank the Kool-Aid. But is it useful for normal people, like people who don't understand robotics? Can you explain your solution without ever using the word robotics or any technical expression and get people excited about it? When we did Google Maps data, we empowered people to have on their phone turn-by-turn directions. We could tell your phone can tell you where to go when you're going to go somewhere. That was useful, and no one knew what that meant. When we build self-driving cars, or I build self-driving cars, that's useful. I think it's useful to be able to be picked up by somebody at a low price point in a safe way. But if I look at my time at Museum Tour Guide Robot or Nursing Robot, that was not useful. Like tour guides in particular work for free. These are usually old men and ladies who want to stay engaged. The entire Smithsonian has an army of free tour guides, and the last thing I'm going to do is deprive them of their meaning by replacing them by a robot. Or, I don't know, maybe mind mapping robots has a function, but it's not that great a business. So the first thing I learned is to really ask myself, can I explain to myself what I'm doing is actually good for humanity? And when you have my perspective, you're going to realize that your time is limited, and I'm usually an optimist, don't get me wrong, I think my life is long. But it's also, time is the currency that you have, okay? So you want to spend your time in a way that's maximally beneficial. And I derive deep satisfaction of being beneficial to other people, including my grad students. So to myself, I would say, when you do research, can you make sure that the research you do is actually really beneficial to society? And for me, societal impact is measured by 2 variables. It's very simple. One is, how much do you move the delta for a specific person, and how many people can you affect? And some inventions are very deep and very specific to specific people, and some people are very broad, and everybody gets to get a tiny advantage out of it. But that product is what I'm trying to optimize. So that's the first thing I learned. The second thing I learned is a little bit more tricky. So the first one is about creating value. How do you create value for people? How do you take your talent out and and make the world a better place. And that's actually surprisingly hard, okay? Even harder is the capturing value. And that's something that I've learned the hard way in many, many ways. And I've entire talk of failures in my life to understand the second part. But in addition to creating value, which we are all pretty good at, when you go into the world, you also have to be able to capture value. Why is that? Well, in the end of the day, you're going to drink and eat and have an apartment and so on, and someone's going to pay for that. If the value you offer is a giveaway, you got to find some system to pay for it. In venture land, where I'm a lot, initially your customer is your venture investor, right? That's really your customer, and you create value to make that person feel good and give you money. But eventually it's going to be your customer. So who is going to be your customer? Why is a customer willing to pay you money? You might give them value, but they might not be willing to pay you. What's the dynamics of paying you? What's the dimension of making money? And that sounds so incredibly superficial. I'm not here to tell you how to get rich, but it's important to understand how society works, how to get your technology not just into the field and make it do good things, but also figure out how is it sustainable as an innovation? How is it sustainable in the world? And to be sustainable, you have to have a cycle by which someone comes back to you and gives you money and reimburses you for it. That part is very far from academia. We don't worry about it. We go and say, oh, I have this great robot, does this amazing stuff. Look at it, it's really good for people. And often that's a good step. It's the right step in the right direction, but it's not sufficient. So if you want to really have an impact on the world, you have to also understand how do you make sure that whatever costs are affiliated with providing your products and services to people to change their lives, how to make sure you can cover those costs. And whether it's a non-profit or a government or your customers directly, who is your customer? Now, I don't want to go too deep into this because you're an academic crowd, but as you go into the world and have an impact, I want this to be at least known to you, give you notice that this is going to come at you, because just being good and doing good to the world is insufficient. You have to build something that's sustainable, that you can actually capture the value you create and use it to further fund the work you're doing, no matter which way you capture it. So these are the kind of two lessons to myself. I just, in preparation of this, I found this quote by a Yale professor: creating value is inherently cooperative, capturing value is inherently competitive. I'm actually not very competitive. I'm really bad at it. I capture very little value in my life, but I created a lot, I hope. But makes me think about the world and to think about the ecosystem you're in. If you're really serious about changing the world, I would make you, hopefully, if you can take a lesson with you, the creation of value is one thing, and be honest about it, run the grandmother test. The capturing value is another thing. If you want to get into it, think about it and think about honestly, see what the opportunities are, how the world works. That's obviously where Silicon Valley is particularly strong. With that, 5 minutes early, questions. Thank you.
Okay, thanks, Sebastian. So, as a senior in our field now, you're actually younger than me. So,
I know. Embarrassing.
What is your impression of this new developments in generative AI over the past year? How do you think that's going to impact the robotics and the world?
So I'm blown away by generative AI, and I'm just starting a company in that space. Like everybody else, I'm just blown away and see the possibilities. I think in robotics, it's long been known, like if you look at the work of Peter Beal and others, that we have a lot of dexterity, like for example, to clean up your house, and we somehow still lack the intelligence. So to me, this is a great way to close the gap. I think the challenge is going to be still to build products that people want, like domestic robots can be very expensive. But I think it's going to be a phase shift in robotics, because I do believe that perception continues to be the hard part in robotics, and that's the work I see is just incredibly exciting to me. Outside robotics, when people ask me on AI, I'd see effectively two dimensions in which AI will radically change all of business, and all of business. I talk to the Googles and the Amazons of the world on a daily basis. One is efficiency, which we talk about. Like the scary version is everybody's going to lose their job. The positive version is we can do things that we don't like to do much more efficiently. Like we have an efficient lawyer, more efficient marketing person, more efficient accountant, tax person, what have you. The second thing I'll see is a hyper-personalization coming at us, where products and services will be extremely personalized, where you have an agent that works on your behalf to do all this stuff just for you, that knows you. And that's another Google in the make somewhere, that someone figures that out, because the value rendered to people is gargantuous. I personally am staying a bit away from hardware right now. I kind of hate hardware because it's just really hard to make hardware work and scale. I think the opportunities, the low-hanging fruit is more in the software world, but the robotics thinking of building agents carries over to the software world.
Other questions?
Speechless. Come on.
You can come up to the mic.
Can't do this to me.
So what do you think is the biggest blocker to make a more generalizable robotics, like with the zero-shot and few-shot capabilities to deploy it everywhere around the world? And how far are we from that?
Yeah, I mean, like everybody, I'm enamored by the progress. And I went to a recent faculty retreat at Stanford Computer Science, and every single professor's talk was about neural networks, which was amazing. Even the hardware folks and the VLSI folks and so on all talked about AI. So it's taking over the world in storm. I think the challenge is to do the last two things I said. Can you add value to people's lives and capture the value? Like, can you build products and services that people really care about? Go a step beyond the shock and awe, deer in the headlight situation, and really think about deeply what is something that can really transform people's lives. I would believe in drug discovery, in medical sciences, in so many fields, diagnostics. There's now a complete opportunity to reinvent a new set of technologies. I think that the moment right now is as big as the advent of the web. And the advent of the web led to places like companies like Amazon and others, or the advent of the iPhone. I think the web, iPhone, and AI are the three big things I saw in my life as game-changing.
I have one other question. At the beginning, you mentioned, I think in one of the 90s projects, I think was like robotics for elderly care. Do you think that that's something that's worth revisiting now, or some of the other projects now with the technology we have?
Yeah, I just saw Yuri Milner, who invents a lot of money right now, like I said, $1 billion in stopping aging. It's more on the chemical side, but aging, more and more people get excited about the idea that aging is something we can delay or stop. That's super interesting. If you figure that out, you have the world's biggest business ever built. So it's actually really interesting. And I'm actually much more sympathetic than you are, because I'm closer to the other side. But yes, so in elderly care, I would say my journey into this field was a bit humbling, because what you really got to do is see the world through elderly eyes and understand what really helps them. And then you find out that there's a spectrum of stuff. Like, one of the moments that I found tantalizing is the moment a person goes from home stay into a facility, often like assisted living, all the way to nursing. And why is that? The reason why this happens is hygiene is an issue, right? So being able to stay clean, food supply, dementia. Can you help those people? And what you'll find is it's a tough field to be in, because you're dealing with a population that's the least adaptive to new technologies. I had a friend to build a cell phone company for old people. When you opened the phone, it had a ringtone, because the people couldn't understand that a phone without a ringtone is still a phone, which you don't understand, but trust me, my generation does. So it's a really hard field to be in. If you're really serious about it, I'd say spend a week in a nursing home and just observe and watch. The reason why I got into it, this is a kind of interesting story. Japan, in particular, had this infatuation with humanoid robots when I was your age. Every lab compete on humanoid robots. It's a bit ebbed down, but 15 years ago, it was a really big deal. And when these professors went to their government, and the government said, what have you done this lately? They said, yeah, we're going to do elderly care. So they tested all these humanoid robots with elderly people. And I would say it was a disaster in my personal assessment. It was just a complete misfit. But when you are do humanoid robotics for 20 years, you can't possibly imagine what you've done is actually not useful. And it's very hard to get behind this and have that self-reflection. So that Japan started a whole bunch of projects, massive money, to put robots into elderly homes, and I don't think they had an impact.
Awesome. We're now into lunches. Thanks, Sebastian, again.
Thank you.